Okay, guys, there are Topolilogy co-founders Kono and Guilty Gyoza. Thanks for coming, and they are going to share why they are building Shoshin and provide the experience that blockchain is not only just focused on finance. Another experience they will share. Let's see what they have prepared. Could you introduce yourself?
Hello, nice to meet you everyone. Thank you for coming all the way here. My name is Kanho. I'm also a South Korean. 한국 이름 똑같은 일이지만 김건호라고 합니다. A little bit about my background. I actually went to middle and high school in Vietnam. I was born here, but our family moved to Vietnam. Went to college in the States, and I have been working in and out of the States, Boston, Korea, and Vietnam a little bit. I think initial understanding of the groups over here, a lot of you lived abroad a little bit too, can speak multiple languages, very talented groups of people in South Korea, so I'm honored to be over here. I went to Harvard for undergrad, and I hosted one of the first blockchain conferences over there, inviting Ethereum Foundation people and other layer ones back then in 2016, 17-ish. And after college, I worked in a startup called The Wolf. It was a crypto to fiat payments gateway. So we wanted to work with merchants so that people can pay with Bitcoin or Ethereum and purchase things offline in retail. So it's a simple solution. You work with the centralized exchanges back then and would liquidate the assets and then pay the merchants in fiat. We actually did our alpha testing in South Korea with iSense PC방. It's like probably the biggest PC방 in Korea, but we had talked with Korean government before about releasing it, but in 2017, I think the Ministry of Justice came up, you're like, oh, crypto's a scam. So everything was in halt. So we had to wait until the regulatory environment was cleared up. But it was taking too long, so we folded the company. After that, I worked briefly at the Ethereum Foundation at Strategy and Growth Department, and worked at a venture capital firm in South Korea for growth stage investing a little bit. And then now I'm working with Guilty Gyoza over here on Topology. And it's funny how we met together. I actually met him in ETH Denver 3 or 4 years ago. I can't remember that much. It's a ETH Denver right before COVID or during COVID. While I was working there, he was identified as one of the top talents from Ethereum Foundation's perspective to recruit to the ecosystem. My coworker had a PhD degree from CERN in Switzerland, I think nuclear physics, and he talked to Guilty Gyoza quite a bit and said he's a very talented person. And he went to National Taiwan University for electrical engineering, went to Harvard for electrical engineering PhD program, which he dropped out. But he also was competitively doing physics international Olympiad representing Taiwan in high school. So my coworker and he, I think, talked a lot and thought that he was a really bright fellow. I then was one of the very few people at Ethereum Foundation from Harvard, so I was more assigned to talk to him and invite him to like private talks with Vitalik, workshops at Stanford for blockchain workshops with Dan Bonet. Yeah, that's how we got to know each other. Ever since then, we've been just collaborating in small little projects for fun, and we started Topology 2 years ago. It's a long journey, but we'd love to talk more about what we do, why we do. It's quite different from other companies. We don't really work on products. It's more of like a experiment, more similar to like a research labs. So some people get kind of bored because we're not really hyper growth or don't aspire to be. And we'd love to explain why we do what we do and the philosophies behind it. Yeah.
Awesome.
I'll leave the floor to Guilty Gyoza to explain, talk about himself a little more. He has a much more interesting background.
It's really nice to be here. I think my background was pretty much covered by Kenho already. I grew up in Taiwan, did college in Taipei, went to Harvard for PhD, and I dropped out of PhD for a myriad of reasons. I think the early days of young people exploring themselves, one of the reasons why I dropped out. And then roughly half a year later, I joined a company called Light Matter. My background was in hardware acceleration for AI, like NVIDIA TPU stuff. But the company that I joined, Light Matter, was doing photonics. So the premise is that this is going technical super fast. But I think Light Matter's thesis is that Moore's law is suffering, and we should explore new technologies to help scale computation. And the way they use is photonics, so like running laser beams on a chip and mixing laser beams together to carry out addition, multiplication, and so on, so we can compute essentially with light. So I stayed at that startup for 2 years. 2019, on the opposite, blockchain became something that I could no longer ignore. So I read the white papers, fell down a rabbit hole, and 2020 February I met Kenho at Denver. 2 years later we started Topology. I think one reason why we started Topology was because 2019 all the way to 2021, there's a DeFi summer happened. We didn't really have a background or particular interest or something to contribute to the scene, but we were interested in different life philosophies that ultimately converged to what we really want to build at Topology, which is about realizing human potential, fostering an environment for collaboration and coordination, and so on and so forth. So at the end of 2021, we came across ZK. StarkNet was becoming available for developers. StarkNet being a ZK rollup can compute a lot more on the work computer. So we decided to make video game-like experiments on StarkNet. And then we started the company because we wanted to do this full time.
He's being very humble, but he had a very fun journey between Light Matter and the PhD program. He worked as a chef at restaurants with Michelin graded chefs.
That was really funny because when I left the PhD, I told my advisor I wanted to cook. And he's like, do whatever you want. It's important to do what you want to do. I think in Chinese there's 先斩后奏. Basically you execute it and then you tell your seniority. So I did it and then I told my parents and they freaked out. Yeah, but I think we're doing Topology now, so everything's
yeah. That's the type of person he is. I admire his courage a lot, because if you think you're doing a PhD program at Harvard and dedicated your probably half of your life in math and science and physics, and wanted to try a new thing and quit probably one of the most prestigious programs around the world to pursue something you love, and I think that tells a lot about himself, and I think it translates into what we're building and why he's working on what he's working on. I always tell I'm the dummy here and he's the real smart one.
What did you study? What did you major?
I studied environmental science and public policy at Harvard. It's nothing to do with this, and I think it had a really interesting journey. So I got in as it's called human developmental regenerative biology. So it's like a biology chemistry major where you study stem cells and do research. So my freshman year I did a internship at a lab, and I was pipetting for 6 hours, and I was like, oh, I don't want to do this for my whole life. I don't know whether people over here have interned at a bio lab, but a lot of repetitive work, but which I think is very important in the field of biology, because you need to be able to prove what you've hypothesized, and it's important to have the data. I think it was just not for me. As you can see, I like doing weird things. Look at my hair and everything. Yeah, and then I moved to government because I was actually very fascinated with the East Asian politics, international politics. So I studied history of, I think it's from the 1900s to up until now. So I think it's very interesting in, I think, the peninsula, South Korea, China, and Japan. Whenever the regional hegemony changes, there's a very tumultuous war happening, and it's the shifting of powers that is very fascinating to me. So I studied there for a little bit, and I actually took a gap year. And on the way from home, Korea, to Boston, I read an article that says oh, the Arctic is melting. For the year round, we now be able to go from South Korea, China, and Japan through Russia and to Europe. And about 80% of the commerce around the world is done through sea, I think 70 through 80. And then of those, I think we have about 60 to 70% going from China, South Korea to Japan to Europe. So I was very fascinated in a way that there's a new path of travel that can happen. And actually, it's actually 7 days quicker if you, because usually you go through the South China Sea, I mean, depending on how you want to call it, that trade, and Singapore and Egypt and go to the Europe part. I think I was familiar with that because the regional importance of those seas dictates the regional hegemony in East Asia, and that's why there's a huge battle between the United States and China about, you know, the sea rights, and Taiwan's over there too. It's like a choke point because everything has to go through there, and China doesn't produce oil, and they need to get the oil from the Middle East. So it's a very interesting area. So I saw that article and I was like, oh, that's a new opportunity. I want to research more into what's going to happen in the world. Not so much about like oh, I love environment, but more so about like, oh, there's a new opportunity that's going to happen, and it's quite interesting. But I ended up not researching on that because in order to research that, I need to find a professor in the University of Alaska. Because at Harvard, there wasn't really professors researching on, I might be wrong, but there wasn't really research on the opportunity of the Arctic's opening up at that point. So I ended up learning a lot about what Elon Musk is doing, and thought that he was doing a really cool job back in the days when the stock price was super low. But I think one thing that I got up from it is that, oh, it's quite interesting when a new technology comes out, a disruptive technology comes out. It's an amalgamation of policy, economics, and also technology. So I think that really translated me to understand at a more of a holistic way of looking at blockchain and how this new technology, I think, impacts both political agenda and economic agenda of the entire globe.
All right, so can we jump into topology things that you guys are building?
Yeah, sure. I think everyone here is very familiar with Ethereum, right? You guys are live and breathing the Ethereum world over here, everyone chanting over it. But are we all familiar with the notion of Ethereum being world computer? So I think how we see this is everyone has their own computer. So your computer right now is your own computer. It's not a global computer where a lot of users can log in and use the compute capacity of the computer. So your computer is your own thing. It's a single player computer. But Ethereum being the world computer is the first, from our perspective, the emergence of multiplayer computer. And if you look at the gas fee and everything, everyone is fighting or optimizing or coordinating the compute capacity of this computer. So because imagine there's one computer over here and we all need to use it somehow, and then we're coordinating who uses what and how much you can use it. That's how we see it as a world computer. In any kind of layer 2, I think in that perspective is looking at improving the compute capacity of the computer. It's similar to how your CPU is getting better over time. You know, back in the days when first computer came about, it's a Mark I, it's a clunky, huge computers. There's no GUI, it's just like a punch holes, and it take this whole room and they can only calculate maybe 1/1,000,000th of the calculation that we can do with an iPhone or anything. So that's how we see about the layer 2 or roll-up space is about improving the compute capacities. And if you look at the history of this machine or the computer, your personalized computer or any computer, whenever there is availability or abundance of compute capacity that comes out, new things are possible. So when Mark I first came about, they were just calculating the projectile of a missile or some calculations, because that's the only thing that you could do, and it'll take the whole building to calculate it. But as the CPUs getting better, we've start emergence of calculations of complex physics, and we've seen the emergence of like the worlds in the computer, like the game worlds, and before then we would have like GUI and operating system on everything. That's how we think about it, and then I think StarkNet or any kind of rollup that you can think about, optimistic rollup or ZK rollup, from our perspective is like bettering the CPU capacity. And I think everyone is familiar with the timeline of Ethereum, the compute capacity improvements. The long-term horizon is for the ZK rollup because it allows recursive rollups, meaning that you can roll up in a rollup in a rollup in a rollup. So our humble projection for compute capacity improvements or projections is probably going to be faster than the Moore's law, because Moore's law is going twice as better. But if you actually think about recursive rollup, that's more like an exponential compute capacity going up, because if you roll up in a roll up in a roll up, that's the exponential number, you can put it over there. Yeah, so we are excited to see what can be done on blockchain on this world computer. Think of it as like we're in an age where the world computer is slow and expensive, and before the age of GUI or operating system or a mouse, because there's no need for mouse because there's no GUI or anything. So think of it as like a Mark 1. And we are quite fascinated to see what can be possible with the improved compute capacity on this world computer. We think that something will happen, but don't know which one is native for this new computer that we're seeing at a global scale, where multiplayer can participate. So that's why we do a lot of experiments and try to figure out. But we love to think that some kind of native infrastructural way of operating system or GUI or mouse, that kind of components is probably going to be needed for this world computer. That's what we're excited about. We're too dumb to think about DeFi or any of these complicated financial instruments, but more so interested in thinking about this flowery future that we don't know when we can actually execute, but the vision is that we want to find what is native in this world computer's next iteration or improvement. With that in mind, we will start Shoshin.
I think we can go fast on the Starknet side. So we've been making experiments on Starknet. It's a ZK rollup. I think it's less popular in a lot of the countries, and there's a lot of stories behind, I think. But I think Starknet is a ZK rollup that we chose because it was the only ZK rollup back in end of 2021. And we wanted to work on a production-ready, at least on testnet level, ZK rollup. The ZK rollup, it basically proves its state diffs and send the proofs to Ethereum, gets verified on layer 1. Cairo is the programming language to program on Starknet. Cairo 0 used to be a clunky, low-level Python-like language, but Cairo 1 is going to look like Rust. So it's high-level, expressive, and safe. So the kind of things that we wanted to and enjoy doing on Starknet, so on the left you have physics, on the right you have AI. So the physics basically this is numerical simulation 101, but basically recall junior high school physics. Spring system, right? The F equals minus kx. X is displacement and F is the force. It's like a linear system, and in numerical simulation, you can simulate a system of these rigid bodies interacting and springs and constraining them. You can simulate them by delta t's over time, and you can simulate how they interact and move around. So we were able to run this as a Cairo smart contract. The reason we want to do this is if, say, 100 years from now, we're living in a virtual world, the law of physics of that world better not be governed by Meta. So the physics of that world needs to be decentralized. And so let's start small. Let's do two little balls with springs. Let's do this on smart contract first. On the right, we have tiny AI. So this is like a 2-layer deep neural network taking MNIST data set as input, and basically it just tells you the handwritten digit prediction. It's like machine learning 101. But we were able to take this not so good PyTorch model and transform that into a bunch of Cairo smart contracts that together carries out inference, and we just put all these contracts on Starknet. So when you do a view function call, it gives you a digit, but you have to supply the vector first, the handwritten digit as input. And of course, why AI? Well, in the future of virtual worlds, there will be a lot of autonomous beings, helpers, virtual pets, and so on and so forth. I think it's useful for them to be able to run in a decentralized manner, not having some backdoors that people can change their behavior. But this is going into a very different philosophical debate of whether AI can be, has a citizenship as same as a human in the world, but let's not go there. Open source projects, there's a lot of those projects happening in the ecosystem. Reason we want to bring this up is because the best way to learn something is to make things, and it's very easy to contribute to these projects. GitHub.com, Keeps Darkness Strange is where you can find these projects. We recommend learning Cairo in 2 steps. Step 1 is to go through Starklings, which is like rustling but in Stark, just to give you a basic understanding of the language. And then make something, because the community is quite welcoming. If you make something, people will tweet and everyone will know you, and you're not part of the ecosystem. So that's the strangeness and warmness of the ecosystem. And let's talk about Shoshin now. So Isaac was our experiment.